Okay, so this is clearly a geometry question, and you guys don't have a ton of experience with this type of question where it's a circle with intercepted arcs is really what's happening. But we have this weird quadrilateral shape in the middle of it, and just to the naked eye, you're probably seeing some symmetry on this shape, and they clearly identified that these little corners here are both 20 degrees. So there is definite symmetry happening. There's a formula that I don't really know if they teach you in geometry anymore, so I'll just go ahead and tell you. But they want to know what is the value for x. So they want to know how big this angle is right here. Well, it turns out that this angle is going to be the same size as this. Whoa, geez, that was supposed to be highlighted there. This arc, like proportional wise. Oh my gosh, be golly, that's terrible. All right, so there's another formula that I have to remind you of it. And honest to goodness, I don't really know what they teach you about circles anymore. I'm sorry, I haven't taught geometry in a long time. This angle right here, the one that's on the other side of the circle, directly across from this blue arc, this guy is going to be half the size of the blue one. So basically, if I want to call this x, then this is going to be half x. So why is that important to us? Well, this angle plus this angle is going to be the same measure as this angle. I keep messing up with my colors here. So this angle right here is 40 degrees, which means how big is this? Hello, pen. If 40 degrees is half of x, how big is x? So half of x is 40 degrees. That means x is 80. Very good. The answer here is 80. That was a really tricky question if you really don't have knowledge of arcs of circles. So if you experience that again on an SAT test, and like I said, the geometry is so sparse on the test, it's very unlikely that you're going to run into a question that uses those same arc theorems. So I guess if you remembered about how the arcs are related to each other, cool. And if you hit a weird question where you're like, man, I just don't know what this is, that's okay. You can make a guess and move on. Remember, there are going to be some questions where you have to move on from. Oh gosh, that's super tiny. I can't read that. So there's this chart about Miss Simon's workday morning drive, and it says that her car from, okay, blah, blah, blah. So the table, it's a table, excuse me, is showing the distance and her average driving speed in miles per hour where there is no traffic delay for each segment of her drive. So there's this, like a multi-part question. I think it goes 37. Okay, the rest of the test is about this chart. Fascinating stuff. It says, one morning, Miss Simon drove directly from her home to her workplace in 24 minutes. What was her average speed in miles per hour that morning? So if you were running out of time, at least you kind of know, like, common sense, a way to guess about an average driving speed, but there's quite a big range of, like, answers here. So we do want to try to calculate this one if we had the time. From her home to her workplace. So she has to go from her home to the freeway entrance to the exit, and then freeway exit to the workplace. So she's got to do all of these, right? And this is her average driving speed with no traffic delay. This is how many minutes, and they want to know speed in miles per hour. So what that tells me is we have to figure out how many miles she drove and divide it by how many hours it took her to drive there. Now, we have a bit of a labeling problem because of the minutes thing. We'll get to that in a second. Let's talk about miles. It is a calculator test question, so you can go ahead and use your calculator if you want. Can you please tell me the total distance, if you were to add up all those distances, please? And they are labeled in miles, so that's good. Is it 17.4? Okay, cool. So it's 17.4 miles. And then normally I would say let's divide this by 24 minutes. However, 24 minutes is not hours, is it? So in order to convert that to a portion of an hour, we would write it as 24 over 60. Now, I think that is, let's see, a nice decimal. If you want to write it as a decimal, you can. If you don't want to write it as a decimal, just be careful that when you type this in your calculator, you use parentheses around the 24 over 60. Type that in your calculator, and you should get, is it 43.5 exactly? Cool. All right. So it says What was her average speed in miles per hour? They don't say anything weird like how you're supposed to interpret the answer. Sometimes they'll say like round to the nearest whole mile per hour. It's the paper that's on the front of the table when you come in. So you're welcome to do 43.5 because you have enough bubble spaces to do that. Just make sure you're bubbling it in. And then the decimal point's up here, so make sure you're getting that guy. And I looked at the answer key from their official website, and they said they would also accept 43 or 44. Because the directions were very vague, they were willing to accept a child who rounded either up or down to 43 or 44. So, good to know. They'll accept all those answers. This last question here is still referring to little Miss Simon and her chart, her table. Which I can't read this question though, so tiny. There we go. Oh, that's a lot of words. And of course it's the last question. So if Miss Simon starts her drive at 6:30 a.m. so she can drive at an average driving speed with no traffic delay for each segment of the drive. Thank you. I do have so no traffic if she starts at 6:30. However, she wants to sleep in. She wants to start at 7. The travel time from the freeway entrance to the freeway exit increases by 33% due to slower traffic, but the travel time everywhere else is the same. So this part right here is going to increase 33%. Anyone know a quick way, something you could multiply by that'll increase something by 33%? What would I have to multiply this by? That would take away 33%. So if I want to add 33% to it, 1.33. There we go. So I'm going to just jot that down as a note. I don't really know if that's what my math is going to look like in a second. I have to keep reading the question. Okay. Ugh. Now, do you ever notice this in math? Whenever they underline or bold something, that usually means like they're trying to be nice, but that means there's some sort of a catch to this question. So how many more minutes does Miss Simon take to drive to workplace at 7 versus at 6:30? So at some point in our math, we're going to have to figure out the difference between like what it used to take her and then this additional amount of time. Okay. All right. So they want the whole trip, right? Yeah. Can you guys do me a favor? Ooh, you know what? I just thought of something. Let's do less work. Since all I want to know is the difference in time because of this extended traffic issue, let's just figure out how much extra time it's going to take us on that middle part of the trip and not worry about the rest of the trip, okay? So let's just talk about this part right here. So 15.4 miles. Ooh. They give you miles per hour. What do you have to do with this miles per hour? Because we're not going to multiply miles by miles per hour. That doesn't make any sense. We're going to divide it, aren't we? Miles divided by speed would give you time. So on your calculator real quick, can you guys calculate that for me? Probably a weird decimal. That's okay, because someone rattled it to me. I didn't write that one down. I did all my work in one step like a silly person. One more time. 0.308. Yeah. And that's hours. Now remember, they want to know how many more minutes. But we haven't actually increased anything yet, so be careful, guys. I have to convert it to hours. What do I have to multiply by? This is hours. I'm sorry. I have to convert it to minutes. Excuse me. What? You don't know what I'm saying when I'm saying total opposite? Okay, how do I convert it to minutes? Multiply by 60. Okay. What is this? All right, cool. So that's how many minutes this trip normally would take her. Now be careful. I kind of misspoke earlier, James, and I kind of poo-pooed your answer, even though I still don't like it, but I don't think I like my answer either. So I said multiply by 1.33. If I did that, what I would be getting is her new time for that segment of the drive, but I don't think that's what they wanted. They wanted just the difference in minutes, right? So how many additional minutes is she going to be driving for? So let's take this answer that we have right now and multiply it by 33%. And this is how many additional minutes that she has to drive for. And it's like 6.0 something, and it does say, look at the problem here, round your answer to the nearest minute. So we're going to round that down to 6. That was a fun question. Now, when I originally did this question, I don't know, I was tired or something, I figured out a whole lot of stuff about her driving trip that I really didn't need. Like, I figured out the whole shebang, to and from, one with the additional minutes and one without, and then I eventually subtracted them. Still got the right answer, but it took me, like, a long time, so that probably wasn't the best way to do the question. But like we said, guys, this is the very last question on the test, so if you got to the end, I know we're not done with our test, but if we got to the end of this section and we're like, wow, this looks like a tricky question, and I don't think I have time to sit through this question right now. It's okay making a guess and moving on. I will warn you, though, because it's gridded response, the likelihood of you just magically picking 6 as an answer, I mean, it's not totally out of the realm of capabilities for you, but, I mean, maybe it is your favorite number. Mine's 7. I would have been close. Oh, okay. Well, there we go. So that's the end of the test, but this isn't the end of the test for us, because remember, we started with gridded response. Now we got to go all the way back. But this is part of the reason why I like doing the test this way, besides like the obvious logic of not being able to guess on gridded response. Now that we're coming back to number 1, I have a little like sigh of relief. I'm like, oh, thank goodness, number 1. This can't be that bad, right? And it's not going to be bad. Remember, there's some easy stuff here at the beginning. So you do get to use a calculator on the remainder of the test. Keep that in mind. Number 1 gives us this weird little line plot thing. According to the line graph, between which 2 consecutive years was the greatest change in the number of 3D movies released? So this is just graph interpretation. And greatest change, we're looking for something with the biggest slope. You see it? I gotta find the right part of the test. Hold on. Huh? Oh, you weren't here for our explanation. You start with gridded response always on a section, and then you come back to the multiple choice in case you run out of time, because we won't be able to guess on gridded response. Okay? So back to number 1. Between which 2 years is it the biggest slope, biggest growth? 2010 to 2011? Yeah, so the answer is D. So you guys are all shy on a Tuesday morning and not shouting things out to me, but I have a pretty good feeling that when you looked at that, you had the answer like within 10 seconds. So remember, we talked about how there's going to be quite a few questions where they take that long. So don't panic when you find yourself spending 2 minutes on a question that's really difficult, because there's going to be just, a few questions coming up where you spend 10 seconds. All right, number 2. And remember, guys, on this test, I know I do a lot of blabbing, but you get a lot of time. 55 minutes is a lot of time to do 38 math questions. It's significantly more time than they used to give on the ACT test. The ACT test is essentially a minute a question, and this has quite a few more seconds per question, if you want to think of it that way. All right, number 2. We have x and f of x. Now, don't forget, f of x is just a very fancy way of saying y, so you have an x, y, t table. And this is a linear function. Which of the following defines f of x? So they just want to know which one of these functions would work for these ordered pairs. There's several ways you guys can figure this out. I notice that every single one of these has a different slope. So for me, what I would do is I'd just quickly find slope. Who remembers how to find slope? We did. We know it's change in y over change in, change in x. It's rise over run. So I'm going to pick my 2 favorite points. These are them, because they're there. And then y2 minus y1 over x2 minus x1. So that would be 8 over 2, better known as 4. So which one of these lines has a slope of 4? Boom, the answer is C. Now, the other way to do this question, this is the way a lot of kids do it, is they just start taking the first ordered pair, x equals 1 and y equals 5, and they start plugging it into like each of the options. The problem with that, and you have to be careful, is sometimes the 0.15 will work for more than one of the answers. So you have to make sure you test them all before you commit to an answer. And sometimes you have to test another point as well. So just be careful. All right, to make a bakery signature, chocolate muffin, a baker needs, okay, anytime there's a baking question or a recipe question, it's a proportion. every single time. So this is going to be a proportion question, sorry. 2.5 ounces of chocolate. How many pounds of chocolate are needed to make 48 signature chocolate muffins? I don't know. All right, 2.5 ounces makes 1 muffin. So how many ounces to make 48 muffins? That would be a good place to start this question. So what is 2.5 times 48? 120. Now, what do we have here? What label is on 120? Yeah, ounces. Notice, 120 is totally an answer. That was nasty, because is 120 the answer? No, they want the answer in pounds. Notice how they underline the word pounds. That was a favor to you. You're supposed to pay careful attention to anything they underline or bold. So in order to convert ounces to pounds, you just divide it by 16 is the easiest way to do it, but you could also set up another proportion where you say like 120 ounces over X pounds equals 16 ounces over 1 pound. So what'd you get? 7.5. Very good. Or if you're a super baker, you already knew that answer. No. I don't even follow recipes. Just throw stuff together. Hope for the best. Oh, this question I love because kids are really freaked out by it, and I don't know why. They want the value of C plus D, which seems like a very random and weird thing for them to ask. But look at the equation over here. All you need to do is isolate that. So what do? Divide by 3. And then the dyslexic in me goes, ooh, that was mean. Look what they did. They put 3/5 as the first answer choice. It's like they're getting me. It's like they know I'm taking this test. The answer is B. C plus D is 5/3. All right, number 6. I know I'm going a little out of order. I'm just going through whatever's on my screen. An online bookstore sells novels and magazines. Each novel sells for $4 and each magazine for $1. Sadie purchased a total of 11 novels and magazines for a combined selling price of $20. How many novels did she purchase? So the first thing I'm going to do, because I know I screw this up a lot, I'm going to underline or highlight somehow novels, because I need to make sure that when I give my answer, I'm talking about the novels and not the magazines. Because there are 2 unknown things in this problem, the number of novels and the number of magazines. We need to set up a system of equations. And I know this seems like overkill because some of you are like, I don't need to tell you what X and Y are. I disagree. What's X? What would you like X to be? I don't care. Number of novels? Okay. So that leaves Y to be the number of magazines. So a little reminder that we're trying to find the number of novels at the end of this question. Keep that in mind. So the first clue is all about money. And it says a novel sells for $4, a magazine sells for $1, and then later on it says they sold a total of $20. So that's our first equation. 4 times every novel plus 1 times every magazine is $20. And then there's one more clue snuck in here, and it's a total of 11 things. Not 11 novels, but 11 novels and magazines together. So that means the number of magazines and novels added together is 11 things. So keep your eye on the prize, guys. I would like you to solve for X. Remember, that was what we're trying to find. So don't knock out the X's. Let's use elimination. Except in order to eliminate it, wouldn't we have to do that? Now, I am trying to save a little bit of time. So if you feel comfortable doing this, you don't have to rewrite the system like we normally do in algebra. 4x minus 1x is 3x. These are going to knock out. And then 20 minus 11 would be 9. So after you divide both sides by 3, you found x equals 3, which is the number of novels, which is what I wanted. The answer is B. All right. A lot of kids try to do that question by the good old plug and chug method. So they like go through the answers and they're like, let's pretend that there were 2 novels. And then they go back and figure out how many magazines there were. And then they go plug it into the money clue and try to figure it out. And that does work. I'm not saying it doesn't work. It's just not always efficient. And it also leaves you with this grand feeling of, I hate to say it, but failure. A lot of kids take this test and they feel like if they didn't do it the quote right way, they don't have a good feeling about themselves when they leave that question. But if you were to set up a system of equations, and then you have this weird like confidence boost, like, yes, I was totally supposed to do that. We talked about this before where I can't really tell you exactly what's on your SAT test, but I can tell you certain concepts that will show up multiple times. In fact, systems of equations is one of those. And this particular test that we've been working through, I've already seen 3 systems of equations. They're not all traditional. This is a story problem. One was real basic algebra, and the other one was like a quadratic one. But they're all systems of equations. So, by the way, we've used substitution twice and elimination once. The other one that we did with substitution, I could have also done by graphing if I knew how to graph by hand. Because that question was on the no calculator part. Okay? Oh, it's a word problem, but it's okay. We got this because I've totally been to Venus, so I know exactly how much we all weigh on Venus. No, that's not true. The weight of an object on Venus is approximately 9/10 of the weight on Earth. Cool. Good to know. The weight of an object on Jupiter is 23/10 the weight on Earth. So you're lighter on Venus, you're heavier on Jupiter. Cool. If an object weighs 100 pounds on Earth, how many, oh, I hate when they do this. How many more pounds does it weigh on Jupiter than on Venus? So I think the safest way to do this question is to figure out your weight on Jupiter, figure out your weight on Venus, and then just subtract them. But don't forget to subtract them, because I have a feeling your other answers you get show up somewhere else here, so be careful. All right. What number are we on? Turning pages before it's necessary. All right, Venus. Okay, you are 100 pounds on Earth, but on Venus, you're 9/10 of that. So how much do you weigh on Venus? Like 90, right? Okay, on Jupiter, you're 100 pounds on Earth, but you're going to be heavier on Jupiter, 23/10. So that's what, 230? Now, sneaky. Look what they did. 90 and 230 are options. This is how they catch kids, right? You do your math and you look over at the answers and you're like, oh, look, an answer that I have. Not done, because the question was, how many more pounds do you weigh on Jupiter versus Venus? So now I need you to subtract these. That's how we're going to get 140. There's other ways to do that question, guys. I'm not saying that was the only way. I just found that to be the simplest way. So I think the moral of the story today that we've learned is they're often going to ask you questions where it's things like how many more, or what is the difference between. So whenever that shows up in my question, I'm going to like circle, highlight, underline the heck out of it, because it's very likely that they're going to try to trick me on my answer choices, and if I forget to find the difference on that question, my other answer is probably going to be sitting there too. It's not all sunshines and roses on your SAT test, guys. I hate to break it to you. All right, number 7, the Downtown Business Association. In a certain city plans to increase membership by a total of N businesses per year. There were B businesses in the DBA at the beginning of this year. Which function best models the total number of businesses, Y, that they plan to have X years from now? All right, we have linear, linear, exponential, exponential. So I guess the fact is we need to figure out whether this is a linear growth or an exponential growth. So they want to increase by a total of N businesses per year. You would use an exponential function if they said things like you're going to double it, it's going to grow, it's going to increase exponentially, you're going to triple it. Did any of those words show up in this problem? No. So we're just increasing by N businesses per year. That's fancy talk for you have a linear growth. So it's one of these, not these. So I guess the difference now between these two options is, would it make sense to start with a plus B or starting with a negative B? And you might want to go back to what B represented to begin with. There were B businesses at the beginning of the year. Remember, your y-intercept of a linear function is your starting point. So did you start with B or did you start with negative B? That's weird. We started with B. It said right away that we were... At the beginning of the year, we started with B businesses. That's the, quote, starting point of your linear function. So that was really just a matter of, is it linear or exponential? And then it was pretty obvious after that. So that's good news. Number 9. In the 1908 Olympic Games, the Olympic marathon was lengthened from 40 kilometers to approximately 42 kilometers. Of the following, which is the closest to the increase in miles? Now, they're not going to try to trick you on this one, so it's all right. They don't just want you to convert to miles or anything. It's the difference, right? So what is the difference in kilometers? Let's just start there. 2. So you need to figure out how many miles that is. And I think some of you might know that off the top of your head. I'm not one of those people, but luckily they told me the conversion right here. So 2 kilometers is X number of miles. And right here it says 1.6 kilometers is 1 mile. So if I were to solve this proportion, I would take 2 times 1, which is 2, and then I'm going to have to divide it by 1.6. Bless you. So does that come out to 1.25? Cool. Very cool. And, oh, you don't we get 8 done. 8 should be an easy question for us. In theory. So I'm going to show you what it looks like to kind of partially do a question. And this question actually is a little misleading because it looks really easy at first. You're like, oh, subtraction. But this first factor of this binomial squared is usually where kids make a mistake. What has to happen when you have a binomial squared like this? You would have to distribute and FOIL it. Like, it's not as simple as like square this and square that and be done. It's like 1.5x minus 2.4 times another 1.5x minus 2.4. Now, I'm actually not going to go through and do this whole problem, and this is what makes kids uncomfortable because they think like their math teacher is going to be inherently mad about this. Like, okay, A, your math teacher is never going to see your work on your SAT. So I don't really care how you get the answer, except for cheating. Don't do that. But let's talk about let's start with like the first terms, for instance. 1.5x times another 1.5x. You have a calculator. Please use it. What is that? 2.25 and x squared, right? Now later on in the question, remember we're subtracting this. So you're going to also subtract a 5.2 x squared from that. Go ahead and collect those like terms for me, so I can at least eliminate 2 of the choices real quick. What is it? I'm sorry? Negative 2.95. Okay. So my lead quadratic term is negative 2.95. So you're gone and you're gone. So it's one of these two. The only difference between these two problems, these two answers, the back coefficient, this one has a positive 12.16 and this one has a positive 0.64. Your job is to figure out what's that back coefficient. So guys, remember, I'm only going to partially do this question. Can you figure out your coefficient from this FOILing problem for me? 2.4 times 2.4? I'm sorry, what? 5.76? And then remember, you're subtracting, and this my Algebra 2 kids keep getting wrong, makes me sad, you're subtracting a negative 6.4. So what are you really doing there? You're adding a 6.4. So your back coefficient is clearly not that, so the answer is C. Now notice, I didn't actually finish the question. Does it matter? Not really, because I eliminated the other choices. That's a little risky, because I'm pretty prone to mistakes, so maybe if it was my real SAT, I wouldn't do that, but it is a way to save time, okay? Partially doing the question. All right, after school today, we're going to continue on that, and I'll post the video if you can't make it.